Hello everyone. Assalamu alaikum. Myself Nabil Shartas Khan, and I'm from Group 26. And for the Task 3 presentation, we have selected this chapter, which is the chapter 23 of which is called Word Census and Word Net of the SLP book. And this is the map we've created. The portion here in the white and blue space will be described by me, and the other parts will be described by my fellow teammates. So let's get started. Firstly, we should know words are ambiguous. The same word and the same exact word can be used in many different things. We know that if we take the example of the word mouse, so we can use mouse as an animal, and also we can use that as a thing which we use in the computer to move the cursors. So basically, there's two simple meaning. In this mapping system, we have talked about word census, and then we've introduced WordNet, which is a large online thesaurus, a database that represents word census with versions in many languages. It also represents relations between senses. Knowing the relation between senses plays an important role because as it involves meaning, there are many relations between them. So let's get started with the first one, and the first one for me is the word census here. So what is word census? The sense of word sense is a discrete representation of one aspect of the meaning of a word. I mean the meaning of the word. So basically, we use a superscript like bank 1, bank 2, mouse 1, mouse 2 to denote this message. Basically, mouse 1 can be what? Mouse 1 can be something, we can denote that as a device which you use in the PC to move the cursors. And again, for mouse 2, we can use it like an animal, like a mouse. Similarly, for the bank, we can see where we, store all our money or the whole the investments in your custodial account. For bank 2, you can use as agricultural virgins on the its bank, like the river bank. This is word sense. So how can we define word sense? To define word sense as the word sense is the standard computational approach of representing a word is called embedding, which is basically a point in semantic space. The intuition of embedding models like word to vector or GLOB is that the meaning of a word can be defined in its co-occurrences, the counts of words that often occur nearby. But that doesn't really tell us how to define the meaning of a word sense. Contextual embeddings like BERT, BRT go further by offering an embedding that represents a meaning of a word in its textual context. And we'll see that the contextual embeddings of this, like at the heart of modern algorithms for word sense disambiguation. But first, we need to consider something. We need to consider the alternative ways that dictionaries and sorcerers offer for defining sense. One is based on the fact that dictionaries and thesaurus gives textual definitions for each sense called clauses. It's an important aspect. Despite the circularity, I mean, there's a lack of formal representation. Clauses can still be useful for computation modeling of senses. It's because it's just a sentence, and from sentences we can actually compute sentences embeddings, which we just mentioned before, that tell us something about the meaning of the sentence. So it's really important. For example, if the definitions make it clear that the right, left offer similar kind of lemmas, stand in some kind of alteration or opposition to one another. Similarly, we can say that the red is a color and the blood is a liquid. Since relations of this sort are explicitly listed on online databases like WordNet, given a sufficiently large database of such relations, many applications are quite capable of performing sophisticated semantic tasks about word sense, even if they do not really know their right from their left. Okay, so that was about defining word sense. So how many word senses does it actually have? So dictionaries and thesaurus give discrete list of senses. By contrast, embeddings, which is basically static or contextual, offer a continuous high dimensional model of training. So basically, okay, let's divide up into discrete senses. Therefore, creating a thesaurus depends on criteria for deciding when the differing uses of a word should be represented with senses. Dictionaries tend to use many fine graded senses, by the way, so as to capture the subtle meaning of the differences. A reasonable approach, given that the traditional role of dictionaries is aiding word learners. For computational purposes, we often don't need this kind of distinction, so often group or cluster the sentence. So this is how we actually, this is the senses words actually have. So the next part is relations between the word senses. So there are many relations between the word senses. First one I would like to mention is synonym. It's basically the identical senses of two different words, like couch and sofa, or vomit or throw up. They denote the same identical sense, even though there are different words. They are basically the relationship between senses rather than words. And then we have autonomy, words with the exact opposite meaning, like long or short, fast or slow. Two sense can be antonyms if they define a binary opposition or are at opposite ends of some scale. So basically, long short is basically complete opposite of length, we can say. Yeah, so another group of antonyms are recursive. That's because it changes or movements in the opposite direction, such as rise or fall, something like that. And the next one we have is meronymy. It's a part of whole relation, like wheel is a meronym of car, like the whole of a whole car. A wheel is a meronymy, and car is a homonym of wheel. And the last one is the structured polysemy, which means the sense of a word that can also be related semantically, in which case we call the relationship between structured polysemy. Like, for example, the bank is on the corner of Nassau and Witherspoon. In this sense, perhaps bank means something like a building belonging to a financial institution. These two kinds of senses are actually with an organization occur together for many words, as was school, university, hospital. Thus, there is a systematic relationship between senses that we might represent as building as the organization. So, relation is all the. So that was all from me, from my part. The part will be my friends and fellow teammates. Thank you everyone for being listened to me. Allah Hafiz. Assalamu alaikum.
Hello everyone, I am Vishal Karnik and I am going to continue the further presentation. So WordNet, a database of lexical relations. WordNet is a large electronic database of lexical relations between words in the English language. WordNet is designed to provide a comprehensive and structured understanding of the vocabulary of the English language, and it is widely used in the natural language processing and computational linguistics application. The database is freely available and can be accessed via various programming interfaces, making it a valuable resource for researchers, developers, and students working in this field. Now, sense relations in WordNet. Sense relations in WordNet refer to a different types of semantic relationship and exist between words and their senses within the database. These relationships help to organize the vocabulary of the English language, provide a deeper understanding of how words relate to one another. Now WSD. Word sense disambiguation is a natural language processing task that involves identifying the correct sense of a word in a given context. This is necessary because many words have multiple meanings, and intended meaning of a word can be depending on the context in which it is used. For example, consider the word bank, which can refer to a financial institution of the edge of a river. In this sentence, I deposited my paycheck at a bank. The intended sense of the word is financial institution, while in the sentence I sat on the bank of river, the intended sense is the edge of river. Now, contextual embeddings. Contextual embeddings are created using deep learning models such as recurrent neural networks or transformers that are trained to large annotated datasets. These models learn to represent words in high-dimensional space based on their contextual user access. And finally, the quality of size of dataset are important factors in the performance of NLP models, as they use the ability of the model to generalize new unseen data. Large and diverse datasets are particularly useful in improving the robustness and accuracy of NLP models. Examples of popular NLP tasks include sentiment analysis, named entity recognition, machine translation, word sense disambiguation, etc. Researchers use these tasks and datasets to develop and evaluate new algorithms and models. Thank you, everyone. That's it. Thank you, everyone.
Hello, I'm Roman Bishash. Today I'm talking about word sense and WordNet. The ID is 20341023. First of all, word sense and WordNet. And my topic is alternate WSD algorithm and tasks. Alternate WSD, word sense disambiguation algorithm and task. In natural language processing (NLP) community, word sense disambiguation WSD has been described as the task which selects the appropriate meaning sense to a given word in a text or discourse where the meaning is distinguishable from other senses potentially attributable to the word. This sense could be seen as the target level of a classification problem that is machine learning. ML seems to be a possible way to tackle this problem. There are four alternate WSD algorithm and task. First of all, we can see the Wikipedia source of training data. Second of all, word in context evolution. Third of all, the task is algorithm as WSD baseline, and lastly, we can see the feature-based WSD. Thank you, everyone.
Hello, I'm Sherry Sabrin, and I will be presenting the 23rd chapter of Speech and Language Processing, Word Synthesis and WordNet. I will present the 6th, 7th, and 8th part of this chapter. So the sixth part is using tracers to improve embeddings. Tracers are used to improve word embeddings which have difficulty distinguishing synonyms. This problem is solved by using antonymy information from tracers. There are two families of solutions: modifying the embedding training to incorporate tracers relations, or retrofitting static embeddings by learning a second mapping based on a tracers. The first solution requires training, but the second is more lightweight. After the embedding have been trained, synonyms are pushed closer and antonyms are further apart according to the tracers. These methods are called retrofitting and counterfitting and have been shown to improve word embeddings. Here in this figure, it shows the improvement of one such method on nearest neighbors to some target words in growth. Then the 7th part of the chapter is word sense induction. In this part, word sense induction, or WSI, is an unsupervised approach to sense disambiguation that automatically creates a set of senses for each word from the instance in the training set. Most algorithms for WSI uses clustering over embeddings. In the training process, each token of a word in a body is assigned a context vector and clustered into a predefined number of groups, with each clustering defining a sense of word. To disambiguate a particular token of a word, a context vector is computed, and the token is assigned to the sense represented by the sense vector closest to it. However, no evaluation metric for this task has yet become standard. And to summarize the whole chapter, it covers various aspects of lexical meanings, including word senses, polysemy, lexical relationships, and WordNet. Word sense disambiguation is a task of determining the correct sense of a word in a context, which can be done through supervised or unsupervised approaches. Nearest neighbors with contextual embeddings and feature-based algorithms are two effective supervised approaches, while the LESC algorithm is a knowledge-based baseline. Word sense induction is the unsupervised task of learning word senses. That is all from me. Thank you.